Great. Okay. Check here. Oh, looks like, quickly. There we go. All right, let's rock and roll. So, today I'm going to do a thing called planning, which I haven't done in a long time. So, what we're going to work on today is, again, our favorite SCTE 35. So I've linked some background information in the chat description, but suffice to say just pretty quickly that SCTE 35 is a binary messaging protocol used to signal ad breaks for things like video players and sort of like video delivery systems. It's used in a whole bunch of places, pretty much anywhere where HTTP live streaming is used, so that's HLS. So you'll see that in Twitch and a bunch of other video on-demand services, like from broadcasters in all different countries and stuff. We're just going to continue where we left off yesterday. And specifically, what I want to look at is probably our number one thing is going to be clearer test output. And what I mean by that is when we try to decode one of these messages, I want to get some more easily read output to find exactly where something went wrong. And the way I'm probably going to do that is this thing, going to implement stringer. Well, that's the string method. Okay, that'll be really good. The next thing I'm thinking of is I want to do test incremental decoding of messages. So right now what we're doing is we are grabbing an entire SCTE 35 message, trying to decode the whole thing, and then just see where it breaks. I don't really like that because we're running into some problems like maybe halfway down, but then sometimes we run a little bit before that, and it's not really clear exactly where something goes wrong. It just errors at some random point. So we definitely need something like that just to try and focus our efforts a bit more. And finally, we're just going to continue, finally finish decoding Splice descriptors. I think, yeah, I'd say that's, and finally we can also, because we'll probably get through that today, and then the next thing after that will be, we can start to test encoding messages. Oh, pretty happy with that plan. So let's get going from the clearer test output. So our test so far, what it does is just going to get this down to something like that. Yep. So what our test does is it reads an entire splice info, tries to decode it, the whole thing, Now, probably what I'd rather do is try decoding all the way up to, say, something like the tier or the command. So try and basically have some different functions that do different bits and pieces there. Yeah, so I'm probably thinking specifically implementing some functions that just maybe decode a command. So that also means that we're going to have to get some known, well encoded commands. That shouldn't be too hard because these things are all just slices of bytes. So we'll just kind of slice a slice, get a little bit of the splice info, test decoding that, check if everything's okay. Okay, great. Then we can just, really hammer on testing, decoding this particular test decoding the commands, and then where we're really getting stuck is test decoding these splice descriptors. Really need to get that down. All right, so let's move this over here. Let's get going. So we've got the code, source code link there for anybody who wants to follow along. I think it's really good to have the code in your own editor, try and hack along with it. That would be really fun. If anybody can do that with me and help, that would be awesome, because man, I'm finding this hard. It's tricky, this low level stuff. I don't have a computer science degree. Don't even know why I'm doing this particular package, but anyway. All right, so let's have a look at our, I'm going to start on a splice info test. Let's do that all the way up to the tier. So we're going to open up splice info. I'm going to go down to, and we'll get the test up as well. Decode splice info. Okay, here's a big bad function. Now, here's a good way to make it smaller. Let's get this. Let's factor that out into its own function. So we'll just just open this up. Already at the bottom there. Okay. And then what we want out of this is a pointer to a command, and I think we'll say we're returning an error, but I don't think we'll need to. Let's get all of there. Now I wonder whether we want to pass in the length or not. So I'm not sure. So what will look like in here is we'll go probably, what I'd like to do is just pass in exactly the correct length into the decode command, because we can read all of that ahead of time. So let's do that. So we're going to pass in so we're going to get the length and then pass in a slice from buffer. So it's going to look like is just here. We're going to write a quick diagram of what we're doing here. So we're going to do decoding metadata. Our command is here, and then we're going to have a command length. And what we want to do is and then other stuff. Sorry about my handwriting. So we're going to pass that into the decode command function. So really what we're doing here is from our current index, so we'll call that, let's say we're going to call it from I to I plus the CMD length. And also we're going to make sure that this is unexported. So if this is unexported, or if it's, let's say private, is that the right word? No, okay, let's just leave it like that. Great. So we don't need the length there. Now this is already much clearer because there we go. This is already way clearer code, because now we're just reading a command. So we have the length already, so this is going to be, don't need that anymore. It's going to be the next byte. 2, 3, 4, 5. That already looks easy to me. So let's go over back to our big stuff here and then pass in the, from where we're up to, which I believe is from 10, since we're on to the next one, 10 to 10 plus the CMD length that we've just gotten out. There we go. All of this. Easy. Look at that. Now it looks like we're missing something here because it should be 10. Let's get our tests running. Ooh. And then let's just double check the spec to make sure that we're getting the right number of bytes here. So that'll be here. Ooh, I love this nice big 123 page spec. So let's go up to Splice info, command. Okay, so the Splice command length, the type, so that's it. So what we do is we get the command length, which we've gotten out of here, and then pass in everything else to decode command. Oh. we got here? Looks like okay, it looks like we're passing in the wrong, we're not passing in enough bytes. Let's double check. Seems okay to me. Because getting it from no, okay, so yeah, this is actually, oh no, reserved. Splice command type is 8 bits, which is an entire byte. So read the type out of that first, you know, at index 0. And then what we want to do is read looks like we'll need a comment here because it's not, I don't think this is super clear exactly what we're doing. So let's look at our, in this case it's a time signal command. Self as a splice time, which is, there we go, okay. Okay, so we're reading a 33-bit integer. If so, extract. So we might have okay, so time signal, if we go back to our Open Splice info. Okay. So so just not quite getting this. We're definitely reading the 1 byte, and then we read the rest of them. I just got this bit wrong. I've got an off by 1 error here. So if the length is, well, we know that the length is 5. So let's say in our test, let's say it's 5. So we're going from, in this code, we're going from 10 to 10 plus 5. So that's the same as 10 to 15, which is 10 bytes, 10, 11, 12, 13, 14, 3, 4, 5. That's wrong. We need +1. So we need byte 15 as well. So it's actually +1. There we go. +1. Yeah, so in our test we're going 10 to 10 plus, we're getting a actually, let's really check this. And while we're here, we'll just limit the tests that are running just so we don't get any other stray outputs. So let's just decode. Yeah. And then now this is incorrect. We need, so we've read, so after this now, when we're done, we've now read from, so this is, say this is index, command starts at 10, and then 11, 12, 13, 14, 15, and then the next is so then this here starts at 16, 17, 18, dot, dot, dot. Now will this be 16? No, it won't. It'll be 10 plus, no, so it needs to be +1 again. There we go. Don't really like the look of this. Oh, that'll do. Okay. So next up, let's try and I'm trying to splitting up. That anymore. Okay, so we've read through all of those bytes and then we just throw them away so then we don't get stuck accidentally reading them again. Now we're back onto reading the length. Now this is going to be the same, we're going to have exactly the same issue again as what we've got. So let's do this again. So here, going to be so where are we up to now? Read that stuff and we've read the command. Now we want to read the descriptors. And there's going to be some other stuff there at the end. So this is going to be our descriptor length, which is 16 bytes. So let's two bytes. So then this here is going to be our, from our buffer, it's going to be from I to our descriptor, oh, sorry, no. From I to I plus the length that we've just read, and then again plus 1. And it looks like this is the descriptor length. There we go, plus 1. Give these consistent names, CMD len, and then the descriptor length. Okay, so we're going to go down into the decode all descriptors. Now I think we're going to have to tidy up this code here. This doesn't, well, not tidy it up, but yeah, again, a magic number here. Yeah, not clear what exactly that is. So let's just start again here. So we've got the, say we've got a buffer of exactly the length that we know it's going to be. So maybe okay. Before we get started, let's commit our progress so far because I think that's a fair, commit. So yeah. Okay, so what the change is and why we're doing it. Why we did this is because it's clearer. To see, whose decoding can be tested independently of, looks good to me. All right, let's go to our, back to the bottom, our decode splice descriptors. So how are we going to start looking at this? So we want to review exactly how long the descriptor loop length. Let's just check again exactly what the, so what I want to make sure of is that the length that we're reading, I'm checking is that what this thing really is. It's used in the Splice suite. Yeah, okay. So it is for all the descriptors. So this is good. So we're decoding all of them here. the thing is that, yeah, what I don't like is happening here is that we're actually reading, well, rather we're passing the entire slice to this function, but we don't really want to do that. We can just pass in exactly the number of bytes that's required. And we can do that by reading the length ahead of time. So what I mean by that is, for a particular descriptor, Splice descriptor, we know that it has a tag, which is, let's draw out the diagram again. So we go here, I'm going to go here. Oh, sorry, that's really let's get rid of all this. So we're going to have the tag, length, the ID, and then the rest of the data. And we're guaranteed to have that structure there. So what we really want to do is read this ahead of time. Change this to that for now. Okay, so we know that the length is going to be, this is a single byte, and then that's, check again how long that is. Splice descriptor is again, okay, it's 1 byte, and then this is 4 bytes, and then this is unknown. Okay. Okay, let's do that. From and then what I'd like to do is knock out, let's make sure the descriptor length exactly what it is of the descriptor following this field. Yep. Okay, so let's knock out that, because yeah. So again, this is now wrong. So when we reslice the buffer, we've read from to plus the length, and then is that right? Have we read? Yeah, 2 plus the length is, okay, no, okay, let's go back to our diagram. So in our case, we've got here, by reading that descriptor, we've taken no, that's wrong. Because the descriptor, no, okay. So the descriptor has to include the length and that. So that means, shit, it's hard. Okay, so the length is, the d-length gives the length of the descriptor after that field. After that field. So that means that the length, so the size that we actually pass into to decode needs to be the tag, so that's 1 plus, oh no, let's do this from the example of our code. So we're going to read in, so we're going to go, so this is at index 0, this is at 1, this is 2, 3, 4, and 5, and then this is going to be from 6 onwards. So 6 onwards. So that means that to decode the descriptor, oh no, and then this will actually be not just onwards, but actually from the length and then plus 1. That's it. Okay, let's try again. That looks good. Okay. And then when we reslice, it'll be that we will have read everything up to, will we have read everything up to length? Okay, let's calculate again. So in our case, let's say, just for shits and giggles, that our dlen equals, let's say, a 12. Okay, so the buffer that we've read in is going to be from 0, 1, 2, 3, 4, ... to 12, plus 1. So that means when we reslice, so the next one is going to be from 12 plus 1 onwards. Is that right? That yellow isn't really clear, is it? I'll just change to red. We'll do this again. So again, for our example, let's say is 12. So that means that our buffer, we're going to have passed in 0, 1, 2, 3, 6, 7, 8, 9, 10. Like that. So then our next buffer will need to be, yeah, actually from that onwards. That's it. So in our case, it'll be that, and then like that. Look at that. You guys saw this short slice, want 28 bytes, have 28. Okay, let's we'll get to that very bad error message in a sec. So now let's make sure we're not doing double work here. So if we're unmarshalling a single splice descriptor, yeah, okay, let's just do that. Just check it. Length is that. Still seems okay to me. How can this be? So I'm reading the length again. Very strange. Okay, the length. So if the length of the buffer from that index is less than Okay, so we are reading the length, and if the length from there to the end is not the same as length, then I'm just absolutely baffled by this. See, here's the problem. There, that's incorrect. So, yeah, okay, so the length, yeah. So, yeah, this isn't, I want to store that, let's say, let's just do this. Okay. I think we're off by 2 here because we're off by 2. So because we're reading the, no, this isn't. Seems to be plus, so it's 2 plus that. And that's going to be this. Almost. So we've read the tag, then we read the length, and then we need, and then after that, the length gives us, so this is actually the, so the length of the, the length of this is the dlen, the descriptor length. Okay. So now we've got an off by one error here. So we need to go back up to decode all descriptors and just double check that we're getting this correctly. There shouldn't be any bytes left in the decode loop. Well, rather, when we're done, we shouldn't have anything left. I think we need that there. So let's check again. Let's put that there. So is that right, like that? Okay, great, that looks correct. So this is going to be that. I think we got it. Now I think we really need to work on what we were talking about before, which is the clearer test output. So let's start with the big old Splice info. Let's go right up to the top. Let's print out something nice. All right, so we really want to make this clearer so that when we do run into a test result like this, we actually get something a little bit easier to read, especially because there's so many other bits and pieces going on in there with hex and stuff. All right. Another day of counting bits. Yeah, that's right. Never stops. Never stops. All the qualifications. Top counter. Oh, no, I can do that. So we're going to, info dot, and then something kind of clear. Maybe we want something like, anyway, let's just do like this. So we got the sub type. This one, the tier is often represented as a hex value. So let's print it out like that when we actually hash x. And a new line. Let's just do it like that. Percent and is just for now, and then we'll come up with a nicer way of printing the command later. Same for the descriptors. And again, we're going to want to, I think we're going to print out this checksum as I think we print this out as well, really what we want to do is print it out the same way it's represented in the spec, just so we're all speaking the same language. So in this case, there's CRC32. Let's look at the examples that they give us. Yeah, it's also a hex value, so let's print it out like that. Okay, and then return the string. That is looking much better already. now what we want to do is maybe print out the command more clearly. So let's find our command struct. Wherever it is. Oh, I think it has its own file. Yep, great. Let's bring this thing out more nicely. So, I'm going to use this strings builder because apparently that's more efficient in what's meant to be used. Okay, great, and we can just use println into it. That's easy enough. Right, so is the zero value ready to use? Great, okay. Okay. What is sipalg? Sipalg. Whereabouts is see that? I don't see that in the code anywhere. Is that maybe in the specification? Okay. Sipalg. Sip. Yeah, sorry, I'm not sure what you mean by that SIP alg. Okay. Where does it come from though? Where is it? The SIP like session initiation protocol? Yeah. Ah, okay. Ooh. Okay. Maybe. Maybe I won't. You know what? I'm not going to implement the stringer for that. I will do the splice descriptors though. So if I go back to our Splice info printing, so let's have a look there. So command descriptors. I wonder whether I could almost write a function that actually diffs the info, which might be quite handy. And then it's going to return a string. Yeah, we're going to have to do this. So this is actually recommended by the lead of the Go project, Russ Cox. He wrote actually I might just link this here. So there was a great talk that he gave at a conference that I actually emceed at, which is fun. Testing. This was at GopherCon Australia about 6 months ago. So what we'll do is, yeah, we'll play this one. There was a section in there. Actually, here we go, readable. Yeah. So if anybody who's watching this is interested, there's this is the one that I'm talking about. So this is about I'll write that in the other chat as well. We've got 2 chats running now, which is a pain. That's a really great video to watch. Okay. So let's build a builder. So oh no, we're going to do buff. Maybe we'll do something, not sure exactly how to, let's copy the format that they use, that they use in the Go project. It's about, here we again, we'll do this as a hex value. So tier equals and then %hex. So this is going to be now our, I'm going to dereference it. There. And then again for our Splice descriptors, whew, wow, this is some boring code. Okay, so we have our silly little diff function. So let's go here. Let's just log the output of it. So it's going to be diff info of 1 and info. Oops. Oh, yep. Aha. Great. Okay, that is a good. That's a good point to just take a quick break. So I'm just going to go to the bathroom and yeah, no, that's actually very good. I'm really happy with that. What I want to do is actually I want to knock out those custom string methods because I feel like this kind of gets us a lot of the way there. Having this diff output is good. So let's just knock this out. Yeah, that's okay. 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 Hello again. So we'll just doing the usual bit counting stuff as a sneaky donkey brought up. I thought that was pretty funny. So yeah, let's continue where we left off. So we've written this, I think is quite a handy little function that just prints out the differences between splice infos, so that we don't see, instead of seeing all of that, we just see the things that are different between the two. So what I'll do is just modify that ever so slightly. So instead of, I think for these structs, it would be really good to get a, yeah, I don't know what those fields are for the life of me. So let's do that first. I believe those are the descriptors. So just a printf on that. Still a lot of junk there. Almost need to write a descriptor diff function as well. Let's do it. That's what we need. This is going to be a little bit trickier just because we test for the type equality. What do I really want to do? Let's just start with doing the basic fields of the Splice descriptor. So let's go Splice descriptor, there we go. So let's do this nicely. The Splice descriptor is going to be if a.tag is not equal to b.tag. Get a buffer to print into. I really want some maybe a better diff output. I need a let's have a look at the yeah, let's do this. So we'll do that, and then we'll print something like the left-hand side is probably need to, let's just make this shorter. Okay, so the is that, and then the right hand is that. Okay, so the descriptors, so let's do it like this. Buff.writeString, then we're going to do the diff of the descriptors. Oh no, we're going to need to do for each of them, okay. Okay, so the descriptor count is different, so then we'll need to just print out the that, so len of a.descriptors, and then the length of that slice, and then let's just print out the actual descriptors. Right. Otherwise, we can actually diff the descriptors exactly. So for I'm going to add it to the buffer, so write string the Great. There we go. That is looking much better. Really, really nice. So let's go to our diff info 4. This test is getting really big, but that's fine. That's fine. Look, this is one of those things that will, you know, it'll pay off later a lot. Okay, let's do this. Print f. Okay, let's just do that. So let's just try and get something more useful out of this. What we'll do is we'll do a type assertion on the different types of descriptors we can get. So let's do type switch rather. Let's do a time descriptor. Oh wait, how do these type assertions look like again? I got type switches. I can't remember. Let's have a look. Don't forget these. The interfaces, type switch. Oh yeah, okay. Easy. So we'll just do excuse me. All right, b.type. Actually, just hold on. Let's just try it without actually getting the value, because I think we can just print it as is. Oh no, maybe not. Oh, so that's a segment. So just do that. So that'll be A and B. That's it. Oops. Great, looking much better. I'll do this, plus. Almost don't want that. Let's just do that. It makes it so much harder to read. Then ID cancel. So restrictions is different. and the duration not quite. Okay, we're going to have to look at how we decode the segmentation descriptor now. So now that we've got a good little test, let's much better test than before. Let's have a look at our segmentation descriptor decoding. Is that right? Okay, so first up, what is wrong are the restrictions. So let's get this correct. So the restrictions are a bit field of 8 bits. So we're getting something really different. Two on 1 and 15. Really wouldn't mind getting a anyway, let's try work this one out. Just the first thing I'm looking at is, why do we, oh okay, yeah, because that's, yeah, okay, so that's, the event ID, and then we just go straight to, the index seems totally wrong there. Why? What I mean is, why are we going from 5 and then all the way back to 1? Can't be right. So let's have a look at our segmentation descriptor and just see what the fuck we're doing. So read the event ID. Yeah, no, this is already totally wrong. So we're reading from index, and again, this is totally, well, no, we've got indexes all wrong here. Let's just confirm what we're passing in. So we're going to go to so we read the so we've read the ID. So yeah, now we pass in like the payload of the descriptor. So this needs to be the byte 5 at index 5 because we've read 4 bytes. So if I go back to, I haven't got my. Main is that if we do our, this is a segmentation descriptor. So we've got here so we're going to get our, well, we've already read the metadata. So like the headers is the things like the, the tag, etc. And then after this we've got event ID, and then we've got some flags. So this is 4 bytes, that's 1 byte. This is 1, 2, 6. So this is 0 to 5. This is at 5, index 5. We've got and then a bunch of other stuff we'll get to in a sec. Okay. Yep, so again 5. And then this is going to be this is going to be 6. So because we're going on to the next byte, so flags, and then we've got here, I'll just make this easier. This is going to be the restrictions. So that's at byte 6, the next one along. But we have something totally wrong. So we've got, so this needs to be 6. And then oh man, this is all so wrong. Oh dear, oh dear, oh dear, oh dear. Six. So then the duration is going to be way down somewhere else. This is going to be at byte index. So we read, oh no, and then, oh no, okay, yeah, and then the next, this is going to be our duration. Which is that's 5 bytes. So that now must be index 7. Let's go again. So 7 to 7 plus 5. slice. That's 12. Let's just do it in our head. So 12. Otherwise, if the duration flag is not set, then instead of going from otherwise there just aren't 5 bytes there at all. So we'll just go from it'll be everything from say if there's no duration, then what we'll do is we'll need to do everything from 7 onwards. So it'll be from 7, since 6 contains the flags, and we know that they're there. So we go onwards from there. So that all looks okay to me. So let's just try that again. What do we get? Okay, so that. Okay, no, we got something wrong again. Okay, we're off by 1 again. Gosh, crazy. All right, so here we've got up to 5. No, we actually we don't want to read. No, read up to 4 because we've got 0, 0, 1, 2, 3. So this is. And then that's going to be at 4, 4, and this is going to be now everything down 1. Oh. Okay. Almost. So we've got the flag of segmentation descriptor, event ID compliance. Should not be, event ID compliance should not be true. So it should be false here. So we're probably not reading the flags correctly, although this bit mask seems correct to me. I'll just make sure that we're reading into the right order. We might have the flags swapped around. So we'll go back to the spec and see the order of the bits. So the first, at least the leftmost in this thing is, yep. And then the second one is the event ID compliance indicator. And then the next 6 bits are reserved, so we throw away the rest of that byte. maybe from the sample, we're assuming that the in our test case that we've got, the event ID compliance indicator, I'm not sure whether that's really set or not, because it actually in the sample it doesn't actually mention anything at all about that particular flag. So it just goes straight from the cancel indicator. If we have these next to each other, it goes from so it gives us the event ID, the cancel indicator, and then moves straight onto the delivery restrictions. So that's a possibility. Oh, somebody. Ah, yeah. Thanks, Mr. Love Pickle. Jeez. It's a good name. Good name. Nice and formal, mister. Thanks, mister. Thanks for joining us. It's, yeah, you know, going through all these bits and bytes is, yeah, so many little mistakes. So at least somebody's there. I can say, yeah, Jesus, it was just a tiny mistake. Just to verify how dumb I really am. Not making big sort of, very high conceptual mistakes. I'm just doing dumb shit. All right. So we've got. Okay, look. Let's skip the. Let's skip that particular flag because. Not sure whether it really matters or not. Okay, the next value is absolutely wrong. So that's these are the restrictions. So what we're getting is something totally wrong. So let's have a go again. So these leftmost 2 bits are flags. So are flags for later. So that explains, I think. Like that. That's clear because there's 2 different concerns there. So I have a feeling that we're not reading the bits correctly. Maybe this bit mask is wrong, but essentially, if we go to the layout that we have in the spec, which is going to be here, something about these bits are not being read correctly. So we're masking the first 2 bits because those are flags, and then we're reading the next 1, 2, 3, 4, 5, 6. Oh, you can't see what I'm doing. So 1, 2, 3, 4, 5. Oh, sorry. 1, 2, 3, 4, 5, 6. Okay. And we want to set them no matter what, even though we've got a this 0 thing here. well, let's check what the values of the bits are even when they're reserved, because sometimes they do say, oh, and if they're reserved, they must be, some value, or they must be set or not set. So this is actually telling us, okay. So I think what's happening here is that this is actually a flag telling us how to set the next 5 bits. So let's actually translate that directly into code. So what we want to do here is go if that flag is set, so 1, 2, and then 1, 2, 3, 4 is greater than 0, then we read in the values of the bits. So this we're going to read that byte, and then we're going to skip the first. We're going to read the rightmost 4 bits, so that's going to look like, we'll just do it like this for consistency. 3. Oh, sorry, no, is that right? Read the next, sorry, 5 bits. So 1, 2, 3, 4, 5. Oh, yep. Okay, so delivery. Okay, not quite right either. Anyway, we're closer. We definitely had a bug. Again, Erica. So I need to put my sunglasses on. That's better. Let's review exactly what the expected value for those. The delivery not restricted flag is 0, so that means the delivery. Okay, so this is like that. Jesus. Okay. Getting 15 again. So the value that we are expecting, let's check. So let's just go back to our test, wherever it is. Okay. So we're expecting these values, well, those fields set. So now we need to check that we've got the correct, whether those constants that we've set are actually correct as well, which I guess will be in this file, top somewhere. There we go. Now let's compare with the spec. Whew. Okay. So I'll just change like this so we can see. Nice. All right. So the web delivery allowed is going to be 1. I think I've got something wrong here. So specifically, what have I got? So this is going to be, our bitfield wants to look like that. So that means the leftmost 3 bits have got to be, well, can be whatever, we don't care. Yeah, here we go. I've got this wrong. So this isn't, no, this is, yeah, it shouldn't be plus iota. I need to, it's the other way around because we've got, so we've got the bits the wrong way around. Let me write this down, because just so I see if I understand it, right? So if this is going to be the delivery restrictions, so let's just call it restrictions, because look, it doesn't matter what this really represents in the real world. We don't care. So we're going to have a bunch of bits here. Oh, hold on. Let me put it right here like this. So the restrictions. It's going, oh, actually, no, I'll do it like this. Okay. 1, 2, 3, 4, 5, 6. Shit. Okay, there's our 8 bits. So the 3 we don't care about because those are just flags. The next one is what they call the web delivery. So let's just call it web delivery. The next one is regional blackout. This one is archive allowed. And then the next 2 are the actual sort of device restrictions. So let's just do, so those together are going to be device restrictions. Now we can see why the code is wrong. So if we put that over here, this value needs to be 3. Like that. Yep. Because we're setting, this is shifted 4, 3, 2, and then 1, and then 0. Shifted, and 0 is not shifted, so. And from there, yeah. So we should do this minus odec. Are we allowed to do that? Yeah, cool. Okay, I'll hide that for a bit. Okay, now let's double check that we've got these device restrictions set correctly. So the device restrictions, it's going to be 0, 0. Yep. One is going to be I don't think that's correct. Is that in binary? It will need to be 1, 2, 3, 0. So this value will be oh man. Okay, yeah, let's go back to our diagram. Okay, so we skip the first 3 bits. And then the next one, and the next one, and the next one after that. So we go, let's do this, so 3, web delivery, regional blackout, archive allowed, and then O1. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. Great. Okay, so this should be OX01. And then the next one will be 1, 0, so that is just O2, and then none is O3. Oh yes. Okay, there we go. Woo! All right. 15 and 15. Nice. Okay, so we have that bit. Those set correctly now. Four, 3, 2. Yep. Fantastic. All right. Next up, next field of the Splice descriptor that we're going to look, the segmentation descriptor is, a bit of diagram in this, segmentation descriptor. Oh yeah. Okay. Next that we're going to look at is the duration here. So we're going to look at this. So we've done the restrictions. We've done all the other stuff. So the duration, I just hate how that's a pointer. I'm pretty sure we need it to be. Yeah, we need it to be because, yeah, for when we do the encoding. To really check whether these values are different, we could maybe add a bit more to the test. So rather than printing, well, we'll dereference the pointer. So when we're printing out our little diff here, this code is pretty, yeah, kind of yucky, but I'm not sure how to do that. Maybe let's move on to the field after the duration. Pass the pointer, so it's going to be the UPID. Because we're getting totally different values there too. So we're expecting this value, but we're getting this. Oh, and this is also incorrect. We're missing the value here, so what we can actually do is just set it all in one go, because we want to capture the value of the flag. So we'll go like that. I think. Yeah. And it's cleaner anyway. Doesn't matter. All right. Next up is the UPID. Okay, so let's get another diagram up. So the UPID in memory, let's draw it out here. Oh yeah, here it is. Okay. So this is a single byte. So the type is here. And then we've got the value. So, but in memory it looks like this. We've got the length, and then we've got the just like the value or the, yeah, so the value. And what that value what that value really represents is depends on the type. So looking at it in memory, yep, that's the type, just from there, that's that, and then we've got from 2 onwards. Yep, apparently. So here we're getting a UPID of 8. Check that again. Yeah, tricky. So the problem we've got now is that we're not getting the value of the, we're not getting this. X08. Oh no, I got that wrong. Smaller though. So the duration is okay, great. We've got the correct duration now. Fantastic, fantastic, fantastic. So now we're reading off the end of our buffer. One, two. Okay, let's check the spec. Make byte 3. All right. Now there's going to be something wrong. Yeah, here we go. So if the segmentation type ID equals case 44, 46, number is byte and then the sub-segments expected. There's something wrong with, oh, we are so close now. We are so close. So what we're doing is we're reading now, so the UPID, we're not sure about the UPID though. Let's return here. Let's return early because now we can check. Great. Okay. Yep. Fantastic. Oh, we are so close. Whoa, that, jeez. It's so tropical here in Sydney. It's raining, it's sunny, raining, sunny. It's pouring down now. Not sunny. Weird. Okay. Anyway, so we are, let's close that. So where we're at now is we are finally at the last bit of this structure. So we've read the number and the expected, but then we're reading off the end of the buffer here. So there's something wrong here. We'll need to read the spec just to make sure that we've got sub-segment number. Yeah, so just checking whether we check us. What I'm thinking now is we're going to check the sample just to make sure this segment placement opportunity start. Not sure. Yeah, see that? I think we might have that wrong in our expected values. So what I mean by that is if we go to our test case, and if we go down to, here we go, here, the type is a placement opportunity start, and if we look at the hex table for that, placement opportunity start, apparently I've got an OX34, but it might not be that. I might have just read it wrongly. So if that's the case, let's just we can check. So OX34 is provider placement opportunity start. Maybe it's maybe the value is actually provider advertisement start, but X34, so provider could be that. So let's have a look again. Oh, you know what? We could actually just read it off in the hex, but okay, let's just check first. So placements opportunity start. Look, fuck it. We can read it from the hex here because we know that we know how many bytes along we are because we're right at the end of the structure. Because we've got, if we look at our Splice info, which I may have a diagram of in here. Yeah. So the only thing left here, this is actually this CRC32. So we're right at the end here. That's where we are. So this will be the this will be the segmentation type. So seg type. So if we look at this, we actually might be able to just. God, this is just crazy, silly stuff. So the end is this is 4 bytes. I remember it's a UID32. So 1, 2, 3, 4. And then we apparently have 2. Just check. So we're in a segmentation descriptor, which is where are we? Oh, yeah. Let's just look at the struct. Our struct. Yep. So we are here. Hey, Geek Pirate. I'm actually just using an iPad, so if it's up here, so I'm just using I'm using and I'm just using the Notes app. So normally I run OpenBSD, but since I don't know, I only just started doing this, so yeah, I just got what I had, and yeah. Yeah, so I just have it like plugged into directly into the iMac, and then it just comes up as like a video, like an input or source in OBS. Yeah, but normally I just have like a normal pen and paper, but I thought, oh well, I'll just use this one here. Yeah, I know. Yeah, I know, and it's all like, how does it work? It's just magic, like, yeah, not good for techie people. But it is, I mean, it's amazing, and like the way you can draw, and then, yeah, that's it. Yeah, good point, good call. Yeah, it is good, like, and how you can draw, and it just, the latency is so low when you're drawing. That's really impressive. How do I'm trying to follow everybody who's talking, because I don't know how do I do this? Follow. Cool. Yeah, so right at the end of the segmentation descriptor, we've got here we go, we've got this stuff, so we've got the and then at the very end we've got 4 bytes, so it's a CRC32. That's 4 bytes, this is 1. So if we go back to the hex, 1, zoom in. This is so dumb. 1, 2, 3, 4. Oh yeah, that's right, because this is actually 0. Oh man, no, it's not psoriasis. It's actually just like regular eczema. Yeah, but I'm even on injections for it. So yeah, my cousin has psoriasis, and we're always talking about the medicine that he's using and the medicine that I'm using. It's crazy. Yeah, just runs in the family or something. It sucks. Yeah. I guess you've got psoriasis then? Yeah. Sucks, man. Yeah. So use lanolin oil. Let me write that down. Okay. Whoa. That's, anhydrous, yeah, I see, so it doesn't mix with water. Yeah, wow, okay. Hectic. Oh, that's cool. Thanks a lot for that. That's especially, yeah, some people say, oh yeah, like you just got to try this or that. But I think unless you really have like one of these conditions, you sort of know how hard it is. Like you try so many different things, and when you hear from somebody who really has it, you're like, oh, okay, I'm definitely going to remember that. That's cool. Good on you. That's, yeah. Yeah, so let's see. I'm so close to getting this now, so close. The segments expected is 0, okay? So that's the number, and then so it's the 2, so that means that the hex is actually so as I said, 1. Yeah, we're going to go from our diagram. So this is actually incorrect. So this is the expected. And then this is the number. And this is all the other stuff that we've already done. That stuff's all good. That's 1 byte as well. So 1, 2, 3, 4. The expected is a single byte, 0. The number is 2, that's what we've got. And then the type is OX34. There it is. Sir Coffee Live. Hi, how's it going? So it is 34. So, I know. I'm not reading this expected. That's it. I'm not reading that expected value. Okay, so let's go back. Let's save that. Let's not return early. Oh no, sorry, I am returning the expected, but let's see what that expected value is, because if it's 0, maybe we shouldn't read anymore. Oh yeah. What was the problem you got angry about? Segments expected is 0. Algebraic data types for C99. Wow. Oh, hold on, wait. I gotta give me a second. I gotta 2 seconds. I'm gonna write this, and then I think if the segment expected, what is this? Whoa. Hey, lazy middle. Provides a count of the number within a collection of segments. So, I guess the thing is that assets one this for new segments such as a chapter. I don't know if we should support the use of vuvuzelas. Just worn out from the when was that? When was that World Cup in South Africa? Was that 2006? No, that was Berlin. That 2010, right? Those vuvuzelas. To write individual bytes from an array into a file. If write always fills up the next 3 bytes. Oh my god, I think we got it. Woohoo! Okay, now I could just go back for this. Oh wait, no. First, I'll just commit where I'm at, and then I am super interested in this stuff. So, script expected. Let's have a look. Yeah. So the message here is, I don't remember the diff. this is this diff stuff that we've done here. So this is going to be I'll just put a link to this, because one day I'm going to look back at this and go, why did I do this? In what is it again? Go testing by example, isn't it? All right, we have now pushed all of that. Let's keep going on the diff. Yeah, okay. So Splice descriptor. I mean, there's nothing much more to say. All right. Great. Very, very happy. So let's have a look at these things it's saying. Oops, where's my chat? There we go. What? People are so much smarter than me. I don't know how people come up with this stuff. Oh, wow. Is it, what? Very impressive. Wow. Right. So let's see. I'm just going to check my progress because I agreed to myself that I'd go through these things today. So let's have a look. So clear test output. Yeah, absolutely. We've done that. Finish decoding Splice descriptor. Yes, absolutely. Test encoding messages we haven't done. In the incremental decoding, we're kind of no, we have that now because we've we refactored it so that we're not just trying to decode an entire huge Splice info struct. So now what we do is we have about 3 different functions there that, you know, decode, you know, like bit, well, like part 1 and then, you know, 2 and then 3, something like it's split up into the main bits of the struct. So that's great. So what does how does fwrite actually oh. I've actually never really written much C. I mean, and you said, Sir Coffee Live, you said, oh, trying to write PNG image with C, don't ask why. I mean, why not? It's cool. Why am I writing this stupid add signaling library in Go? It's cool. Okay. So from here, oh, zip library. Oh, like the session, yeah. Yeah. Yeah, session initiation protocol, session something protocol. Yeah, that is cool. Yeah, I'm wanting to once. Let me get this right. So now that we've done this, for the most part, we've done this splice info. So going back to the we should very soon be able to decode that fully. And then we can move on to something, maybe something a lot more interesting, because this add signaling stuff is just, I just kind of started it as a, you know, a general software engineering exercise, but, you know, add signaling, come on, who cares, right? Super boring. I just know that there was a package that was used in production that I didn't really like, so I thought we'll write this one instead. And people can watch me struggle as I go. But people have been super helpful, actually. Yeah. Oh yeah, cool. Yeah. Okay, so we just trying to think now. Okay, so there's still one leftover bug. Oh, how long have I used Go for? Oh, yeah, that's a good question. I think since 2000 and really properly, I think 2018 or 2019, something like that. So maybe 6 years. Yeah. How about you? Yeah. Oh, wow, nice. Oh, so that was in 2009? Cool. Yeah, yeah. Wow. Yeah, cool. Have you I know this is going to be a weird question, but have you seen it change much? I think obviously the language, yeah, I've read some really historical Go that didn't, like before version 1. But have you seen its usage change much over those years? Like say from 10 years ago. Yeah, the way people use it, that sort of thing. Because I guess the language is like very stable. Context, yeah, yeah. Some types, yeah, okay. I guess the next major thing will be, yeah, I saw a couple of bits in the standard library that use the generics. I can't remember where though. I still haven't used it, but I haven't done all that much programming, to be honest. Yeah, yeah, I saw that the blog post. So what are they starting with? The math rand package. Should be interesting to see what comes out. Oh, the JSON package. Yeah, that's right. Yeah, there was quite a big. I remember reading through the proposal. It was really like actually, to be honest, actually I can't remember now. But yeah, I remember reading through the proposal. Yeah, so let's. What I'm gonna do now is just. Yeah. Yeah, like I guess the yeah. Yeah, even the Go modules was a pretty big thing. I remember I think I started using Go just before VGo was released. And so, when you had GoPath and all that, I actually didn't mind GoPath. It's sort of, yeah, but I understand, of course, about the modules, and versioning is a big thing. Yeah. Yeah, same here, yeah. I think the fact that Yeah, yeah. On the one hand, it's great that there's more like dependency tooling, but then, the idea of dependencies in the first place is like, like, of course, sometimes, but other times, yeah, you can just, yeah, like they say, a little copying better than a little dependency. Part of the motivation for this little project was, I had quite a few dependencies, and I thought, oh well, when you're just shifting bits and bytes around, I didn't see much point in, having all those dependencies. Oops. Oh yeah. Oh yeah, this yeah. Where did I see this? Was it maybe at the GopherCon in Australia? No. Yeah, I don't know. I can't remember. Yeah, great. Plan 9 color palette there. Love it. Fits right in with my editor. Look at that. Wow, beautiful. Dang. That is actually, yeah, that's oh, have I seen these? I feel like where have I seen that? I've seen this. I remember that from somewhere. Are there other? I've seen that person somewhere. Okay, yeah, maybe, yeah. Oh, makes money from, oh yeah, nice. Yeah, I was just curious, yeah. Yeah, these things, all these little things oh wow, includes all of static check, yeah, right. Yeah, this little thing, like just these little things really, yeah. Good idea. Uncanonical key, yeah. Oh wow, now that, yeah. Yeah, I know. Like even, so you know where it comes from is like the date command. And then like you know, it's 2006, blah blah blah. But every time, even I go, okay, well, it's from the date command, therefore I can just run the date command to see it quickly. But even then, I look at it and go, huh? Swigs for days. Wait, what? Oh, is this? That might be my friend. Anyway. Yeah. Cool. All right, let's Matt. No, Matt. No, I know Matt's username is different. Oh, it's Reese, isn't it? Yeah, cool. Just subscribe to that blog. RSS is good. All right. So the next thing I should really look at is yeah, well, certainly that CW index, that's clearly wrong, and that's way up early on in the struct. So CW index. I thought you have lo-fi hip hop always playing in your headphones. I didn't know that you took those headphones out actually. Seems funny. So this CW index should be pretty easy. It's just a single byte. And why? Let's check the spec and go through Splice info. CW index is just a single byte. There might be some special values. In Okay. So this really should be, so what they're saying here is that if we're encrypted, then this has a value, but if not, it should be 0. So what we should really do is just do this: if info encrypted, then do that. Great. Okay, easy. Next part is, just leave this, let's do a new plan. Let's go here. Now it's tonight, at least in Australia. So what we'll do is oh yeah, I saw that. Yeah, I'm actually surprised that program has actually made it out into the world. I didn't think that would ever happen. Matt actually did most of the work on that. He did actually all the work on that. I don't think I ever touched it. Not that I remember. Oops. So one of the things that we want to do is just put this here. Yeah, it does, which is yeah, I'm not so sure about not so sure about that software. But I don't know. I'm not so familiar with it. Actually, I think that's it. I don't really care about the Yep. Bad, I know. Almost 5 p.m. Okay, so our next up is check the timestamp in Splice info, and then after that we can add a new test case. So next test from the and then let's say that seems all right, just like that. So there's a few more people here now, so maybe I could do a little bit of background information or something if anybody's interested, or I can just keep hacking away. I don't know how you're normally meant to do these things. I just thought it would be a fun idea to, yeah. do this out loud rather than just alone, yeah. So the timestamp in our Splice info, I say timestamp, yeah, it's this presentation timestamp, PTS. Oh no, sorry, no, that isn't right. It's the no, it's not. It's it's not timestamp. It's the the other thing we'll want to do is decode the other types of descriptors. So right now we're only doing the other descriptors that we can get are that. So there's time, rotation, there's audio, and there is available or an Avail, DTMF. Yeah, I think that's it. Okay, so let's go back here. Oops, like that. So in our segmentation descriptor, we're not, and that's a duration. Okay, so let's go through that again. So the so we're going to go to the coding, decoding of the descriptor. Okay, here's our, so there's going to be a bug in here somewhere. So the duration is what we've got here, and it's a 40-bit unsigned integer, and it's got these bits here. So because it's a pointer, we could just very quickly dereference it and just see exactly what value we're getting. Just do a debug print, and then so we're getting that, and then we'll check now in our test case, which is wherever it is. Oh, here we go, sample. Okay, so we've got the duration is here. It's that hex value. Okay, so what does that actually mean? Oh, I've already done this. Oh, great. So actually, exactly the same. Okay, great. So we're all good. So we're decoding the duration. Okay, so let's go down and tick that off. So next up will be what is different here then? Nothing, it's actually the same, I think. Oh, there. Event ID compliant. Ah, yeah, okay. So this field in the for our particular test case in the specification, it actually doesn't say whether this flag is set or not. So yeah, I mean, it's a bit frustrating. We've when we specify like the struct value that we expect, we're actually saying that the segments in the segmentation descriptor, the value cancel. Okay, so we're actually not even saying, so we're just leaving it unset, or which is just false. So I'm not sure whether we need to it's annoying because then I think that test would actually pass. I think so. Let's test. So we've got the restrictions, event ID. So after event ID, we'll do. Let's just set it to true just to see what happens. Wow. Fuck. So close. So close. So close. Just this tier, which has always been a problem. Oh, okay. Cool. Yeah, no worries, Victor. Thanks for joining us. and good luck with your exams. Let us know how you go. That's in the, I've got two chat things going here. I've got YouTube and Twitch going for some reason. All right. Okay, so next up will be, let's have a look one more time at this tier. Let's double check that we're doing our bit mask right. So we're reading, let's go right to the spec just to see the bit layout. So we go to tier is in Splice info, okay, so Splice info struct. Okay, so tier 12-bit value. Let's see the layout. Tier, okay. All right, that's fine. So what this means is that we're going to have, so let's go down. So tier looks like this. We're going to have read it from two bytes, but actually we're not, it's a 12-bit value, so we're going to have 8 from here, and then 4 from here, and then the rest is, that's used for the some other field, so that's command length. And then that holds the tier. So what we'll want to do is, in our code, we can move that out of the way. Let's put this, let's read where our tier is. Tier, okay, here. All right, so we're going to read so in our case it's going to be index 7, and then this is at index 8 of our buffer. So we're going to decode the integer from 7 and 8. And then masking. So the mask is going to look like, so we have 1, 2, 3, 4, and then 0, 0, 0, 0, because we don't want any of these values, we don't care. This we want, and this we want, so 1, 2, 3, 4, 5, 6, 7, 8. And then in hex, that's OX, so F, 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 0. So our mask should look like this. I think. So if I do this, will I get a different value? So we want OXFF, we got OXFFI. It's funny because compared to the other things, this bit doesn't seem too hard, but for some reason I'm not. I might need to shift the bits along. But I didn't think I'd need to shift bits because I thought this package did it for us. But I might be out. If I shifted it along, so if I shifted it along, no, sorry, 4 positions, then we would get the value that we really want. So what I mean is that in our diagram, we'd shift everything along 4, which means that our new value would actually be, in binary would be 0. Oh, sorry, our new value would be 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would be it. Something about the way that yeah, not sure. I mean, this actually gets us the value. It means the test actually really finally actually passes, which I cannot believe. I'll do this. I think we should actually. Oh, motherfucker. We did it. Holy shit. 6 days of work to get that one test passing. Oh, man. Programming is a weird, weird job. 6 days, one test. Can't believe it. Cannot believe it. Thank you, everybody. I can't believe. Fuck. Why do we do this? Stepping through with a debugger. Yeah. I've never. Have I used debugger before? Oh yeah, I had to do it for a really weird, not a weird, but let's say a Node.js project that had a bunch of the code was very difficult to read. So, and they needed a quick fix, so we just stepped through it with the debugger, and that was probably. And that debugger is that's delve, isn't it, in Go? Maybe it wouldn't have taken me 6 days if I used the debugger. Maybe it would have only taken me 5. Only 5 days. Yeah, good call, yeah. Oh my god, I cannot believe we did that. I think my brain neglects my brain as well. I feel like I should have it in me to just be a debugger. Like, can't I go through one thing at a time? But I can't. Can't do it. Wow. Okay, let's look, to get a nice clean parse message, let's get rid of that. Let's get rid of that. Oh, the decode, what is it, loop? Okay, where is it then? Wait. Oh. Yeah. Yeah. Look at that. Oh. Yeah, see? All it took to get the code to pass was only 2 extra lines of code added. Six days, 2 lines of code, yeah. All right. So this is its own commit here. It's going to be this is the boring part. Look, I don't mind doing these. Let's write this here. System, whoops. there's the reason for that too. Now, it might seem weird that I'm writing this, even though I'm only really writing it for myself and for anybody else, but this is that type of thing when you go back and you look at the bugs that you introduced by these commits and you go, oh, that's why I did that. So, yeah, very useful to okay. So what we can do now is actually try to we could add the next sample from the spec, which now should be a lot easier because we've, you know, done a whole bunch of work to make adding more cases easier. So let's try. Oh, more people following. Sorry, I don't know how to keep. Yeah, right. Thanks for joining us, Rebel Elder. I will follow you back because people, I just want to see what everyone's doing. It's, people have got, see if I can busy. How do I see, I don't know, I seriously don't know how to use Twitch. Okay. All right. A lot of people have been asking about the text editor. It's funny. I probably get a lot more questions about that than I think I've gotten a question every single day. So I've been going for 6 days. Every day I've gotten at least one question about the editor. I guess because most people are using, you know, VS Code or Vim. I don't know. So when you see this weird yellow background, then I don't know. I really need to get the OpenBSD streaming set up, because yeah. Even more questions if you weren't using Go. Oh, like if I was, do you mean, oh, like if I was using some weird language or something? For eBSD. Yeah, yeah. Cool. I have never tried NetBSD. Okay, let's add another test. Splice insert. Yeah. Yeah, that's true. Yeah, yeah. I actually I didn't know that they were the same ones who did Go. Yeah, I found Plan 9 and all of that, and I thought, wow, this is super interesting. So I was, you know, playing with Plan 9 and all that, and then I think it was a couple of years or a few years later, I was really wanted to learn programming, and so yeah, that's it. Yeah, so then I was what was I saying? Yeah, so I was playing around with Plan 9, and then some years later at work, they needed somebody to program some stuff, and I said, oh yeah, I'll give that a go. and they didn't care what language I used. So I did some searching and I found Go, and I thought, oh yeah, that, like, I really like the feel of it. And then I found out, I guess a year or two later, that they were the same people. Yeah, Sam I use too, yeah. Yeah, Sam is, yeah. I'll use Sam more on Plan 9, I guess. I don't know why. I just like Acme, you know, the way that I've written a few, you know, programs for Acme, and so, you know, the way that Acme, you know, exposes itself as a file system, it's just made it really easy to write programs to use from Acme. So I guess I just tend to use Acme more. But the editing language from Sam, oh yeah, it's amazing, you know. One of those things that is kind of weird at first, but then, yeah, when you don't have it, it's feels weird without it. Just using normal regular expressions instead of, like, you know, the structured regular expressions. I think, oh God, I feel so lost without it. Okay. Oh yeah, no, I'm always doing some, like, you know, especially that this, you know, the way you can go, you know, like you extract, like, say you want the word, you know, like samples, but then you only want sample. I mean, that's brilliant, you know, like that, you know, these sorts of commands, yeah, brilliant, you know. Oops, helps if I put in the right bit. This sort of thing, I think is just, that's, you know, brilliant. Whoops, no, good if I typed in my thing. Okay, so Splice info. Whew. Subtype. Command length. Okay, so the command that we're dealing with is a let's put this here. Command type. and the type of the command is insert, which has all this junk in it. So let's have a look at the spec for that. So the event ID is that. Just need to put this. We'll do go doc. Good morning. Good morning. Good evening from Australia. Out of network. Okay, so cancel is false, so out of network. Prog. Duration immediate is true. Looking at these values here, duration. Cancel immediate. Yeah, we've got immediate is true, out of network is true. Oh no, sorry, immediate is false. Like that then. Okay. Splice time. Okay, so this is a duration, it's a break duration, return true, duration is unit. I'll just do that. Okay, going down, down, down we go. So break duration is done, program ID is 0, okay. Available number is also 0. The avails expected is 0, okay. So insert, oh yep, okay, so that's our insert command done. Okay, so the next field is of our next field of the splice info is going to be after command is descriptors. Okay, let's see what type of descriptors we've got. An Avail descriptor. Okay, so I can't remember how we represent that. Avail descriptor. Oh, beautiful. Just a uint32. Okay, so Avail descriptor. and the value is this. Is that it? Oh, nice. Wow. CRC32 is going to be that value there. So are we really just going to run this and just see if it works or not? I mean, in theory, if our code is really good, now that we've, implemented, we've written all this extra code, we should just be able to, our code should just be able to decode this string just fine. There's a bunch of to-dos in there. I mean, like in the sense that, what I mean by that is, we've done the segmentation descriptor. So now we're checking we're going through this one. So let's see what happens. Let's see. Oh. One. Oh, missed it. What have I done? Valid composite. Oh, what have I done here? So the Avail descriptor, so our Splice descriptor is an interface. And I'm pretty sure that the Avail descriptor satisfies that interface. Data ID tag, yeah. So there's just some weird syntax thing here, hold on. Avail is a, oh, maybe like, just do a literal like that. Oh, I thought it worked first time there. Wow. Okay, Rebel Elder, you're right. Didn't work first time. Oh yeah, okay, we actually just haven't even written the code for that. Okay, great. So let's, yeah, okay, easy. All right, let's go through our, assumed type is a splice insert. So we've got an insert. Let's decode this thing. So insert. Let's just bring up the bit. Bring up the table so that we know, because there's a few extra things like length and stuff like that that we'll need to take care of that we don't use in our struct. Well, that we don't expose. Splice insert. Okay, here we go. Alright, so we start off by reading the ID. Okay, so we're reading for the next 1, 2, 3, 4. Yep. For instance, there I would have just put a G kind of in front of it. Yeah, you know what? That is actually a good idea. I'm going to try and remember to do that next time. Yeah, it is funny. And also, oh, actually another thing is, it is funny to see other people's workflows. And then what's really weird is since I recorded this, I watched back one of the videos, and it's so weird to see yourself working because you don't notice the weird things that you do. Like, yeah, I don't know. Like I noticed that I would like click and click and click, and I said to myself, "Fuck, man! Like, stop clicking." I didn't realize that I was doing it. Okay, so we're going to check the value of the leftmost. Let's might actually write this down here. So we're doing an insert. This is what we're doing, and we're going to okay, so this is the ID, that's 4. But the next byte has a cancel, and then have a bunch of other fields that only show up if cancel is true. So might have this. Okay. So we check if the what value is that? That's again one of those things. I suck at these hex values. So it's the first. Oh, so that's 0, 1. No. It's 1, 2, 3. 1, 2, 3. So it's 0. So that's 0 x 1, 0, 0, 0. What is 1, 0, 0, 0 in hex? Just A. 8. Okay. Okay, so what we're doing now is, I'll just run that out. We're checking all these other flags. So all of those flags come in 1, 2, 3, 4, 5 bits. So this is going to be some flags. That's 1 byte. Actually, just do it here. So the flags are going to be from all the next 1, 2, 3, 4, 5 bits. So let's go. From the next byte. So out of network true. Back to my hex table. That's 40. You know what I should do is do a, I think it's easier like in this case, because then we can just clearly see the values just going down by 1. I don't know, I mean, yeah. I really do wonder what the idiomatic way to do this stuff is. So if anybody knows, I'm super curious to hear. I mean, if anybody wants to say anything, I'm super curious to hear, really. Never get to speak about this sort of thing. My girlfriend goes crazy if I ever talk about computer stuff. Immediate. Oh, oops, did we miss a bit? Oh yeah, no, we've missed a few bits there, hold on. Okay, so out of network, program splice flag, duration flag is, okay, so, oh yeah, okay. Yeah, sure, happy to do that. I don't know if, yeah, there's, let's see. So, I think I have some notes. Oh, no. Yeah, okay. So I'll just quickly hey, yeah, I am. Yeah. Oh, watching without audio. So do I have to click yes. So see, that is directly here. Oh, okay, cool. Yeah, yeah, so it's just plugged directly into it, like here. Ah, that's cool. Okay, so I can just do it like this, why not? So, SCTE35. As I've written, oh, sorry, let me see if we can see. Yep. Okay, so this is a binary message format that you'll see being used to signal ad breaks in video players, in like encoding equipment, and actually was originally used in like cable set-top boxes back in the days when people used those things. But for whatever reason, they're still using them today in HTTP live streaming, or HLS. So that's how we're watching this stream now. So an HLS playlist consists of just a plain text file with with values separated by new lines. So everything beginning with a hash is a tag. Whoops, ext. And then everything otherwise is just a video file. So let's call it like segment1.ts. So your video player, your player will actually download this file by usually a GET request, and then it'll actually like play the video on your, on your device. And then it'll only be about 2 seconds long or something. So as you read through the playlist, you go down, your player will keep reading it. Eventually you'll hit a tag that will be something, I've written discontinuity here, but I think it's actually like date time or something, I can't remember. It's not really important. But what this has in it is a base 64 encoded SCTE35 message. So when we hit that, our package will be able to, CD1. We actually want to be able to, we want our package to be able to, like here, what we were working before was Splice info. We want to be able to, here we want to be able to encode, but then we also want to be able to decode. So once the player hits that, you'll move on to the next thing. It'll play for 30 seconds or whatever. And then you'll just continue where we left off. So we're on segment 3. So then we'll go down to segment, and then it continues on from there. So the way this was, I guess that's it really. So this Splice info here, this normally contains a timestamp or a duration, which just says something like 30 seconds, 90 seconds, something like that. Yeah. So at a project I was working on, they were using this, a package from Comcast, written in Go. But as I've written here, like it was almost, it's something like 4,500 lines of code or something, I don't know. And it had a bunch of external dependencies. So I thought, well, why not try and write something without the dependencies? So first I tried to refactor it so that it didn't use the dependencies. But you know how it goes with these things. You sort of start chipping away at something and then you realize, oh God, this is like, we don't need any of this stuff. So I just started deleting things, and then that's where we're at now. I think I don't really care about ad signaling. I just thought it would be a good exercise to try and learn more about this kind of lower level programming. And also at the end, I want to compare. That's one of the great things about Go, right? Is that the standard the standard library is really, I don't know, just everything fits together really nicely. So when you bring on these other things, it's like sometimes it fits in with the, with it feels idiomatic, but other times it feels like, like some Java developer wrote the thing and you have to use it like you're using some Java thing or, some Python thing or whatever. And we all know about security problems with relying on so many dependencies and all that. So I just thought it would kind of be a good software engineering exercise to work on some kind of package like this, have some better tests, get rid of all the documentation, which was just copy and pasting from the spec. Like, who cares? We can just put a link to the spec and people can read it if they want. Yeah, that's the that's where we're at. Is that clear? Does that kind of make sense? Let's see. Cool. Yeah, so the source code is, I've linked it at the, I linked it in the chat, I think. How do I? Yeah, so I've linked the source code in the chat for anybody who, oh nice, lucky. I wish I had tea. I've got some cold tea here. Yeah, so this is where we're up to so far. So within the Splice info, there's a bunch of other stuff. Oh, there we go. Yeah, so I should really link to just the code here. So for example, a Splice info, type Splice info, yeah. So we've just been working through just encoding and decoding bit by bit, byte by byte, each of these fields. This Splice descriptor has been particularly tricky, I guess. But of course, there's also just been these sort of problems that I think people are used to when they're doing this kind of level of programming, is just these tiny little off by one errors, little alignment issues where you think you've read the whole thing, but you've got one left over, which then affects the next thing, and then everything else after that is fucked up. So this has been a good exercise, I guess, to feel that pain. So that, yeah. For now, I'm mainly writing in Go. Yeah, I've never done. I've been on Java projects, but more as like a SRE or sysadmin or whatever people call it now. I guess I came to Go from like an SRE or sysadmin background, so I was always doing like Linux server administration or whatever. And so I learned a lot about, I spent a lot of time doing like Unix stuff. So when I needed to start writing software, Go made sense just because it feels, how do I say, there's a lot of sort of Unixy stuff in there, things like pipes, and the concurrency is interesting. Yeah, so it kind of makes writing that sort of software for Unix-like systems makes it quite easy. So yeah, that's how I got into it. It was just the type of software that we were writing at the time, if that makes sense. For example, I've barely ever worked with, like MySQL or Postgres. I've just basically never written many CRUD web apps. Just never done it. So I really, yeah. So sometimes it's hard to find work, I think, because, I don't know, actually. Maybe it's just Australia. I don't know. Yeah. So, where's our new plan? Here. But yeah, I hope if you're interested in Go, maybe this inspires you to do some other projects with Go or anything really. I'm sure you can do the same stuff in Java. I like Go though. Feels right for me. Oh yeah, we'll wait and see. Yeah, well, yeah, yeah. These shifts or transitions. I mean, for me, I found it really hard to. I mean, even go from doing that sysadmin stuff to software development. But it's been great fun so far. A lot of fun. Okay, so I guess we'll try and continue where we were, which is, there we go, decoding the insert command. So an insert is, actually we can just have this up. Yep. So insert is again, another one of these lovely bit packed structures. So we're just going through it bit by bit now. So we've read oh yeah, that's right. So this is incorrect so far. So we're reading the out of network indicator. We're actually going to skip over this program splice flag. Now that's just because I remember that because all of this stuff is deprecated, and I think for kind of like a proof of concept or project like this, yeah, I mean, who cares about the deprecated stuff, like this is, this spec is already super legacy, like to implement like the legacy, yeah, no, we can't do that. So, say a bit bit 7. I feel like I've written this already. Maybe I haven't. Anyway, okay, so now we read to check if the duration flag is set. Now again, this is another one of those ones that we're not actually storing, so we'll probably let's come back to that later, because we have even some other flags we need to check beforehand. So let's skip that. The duration flag, okay, and then the next is the splice immediate. So this is actually going to be 5. And then immediate, and then ID compliance is at position 4. And then the next 3 bits are reserved. All right. So now what we want to check, according to this, is there can be a splice time structure in here. If program splice flag is set, but we're always assuming that's set, so okay, and the immediate flag is not set. So let's do this. So if not immediate, let's read a splice time, which is splice time. Again, this structure. Okay. So, geez, I feel, I'm sorry, I just feel like I've already done this. I don't know why. Maybe I've. Command? Hold on. Okay, we've done encode but not decode. All right, let's just keep going. Always easy to delete code afterwards. Deleting code feels great, so let's give ourselves an opportunity to delete code. Feels good. Okay, so splice insert. Okay, so splice time. So splice time. So splice time is, again, one of these bad boys. So it's probably something like a so it's 5 bytes. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, great. All right. I've definitely written code to decode these, to decode this. So I feel like it might be time to refactor so that I can reuse it. Let's do that. So put this over here. The duration, yeah, it was in here. this is the code here. So I say let's oh, that's dead code. Maybe we can just copy this for now. Yeah, look, if it's just one time, let's just copy it. It's only what, 3 lines. So here we're going to be going from, this is index 0, 1, 2, 3, 4, 5, 6. Or not. So we're reading from seven. So we read the flag, so then the next shit. The next one along. 8 to 8 plus, the length is going to be, so here we're reading yeah, duplication is fine, yeah, especially when it's just a couple of lines. So here we're reading from, let's just do this again, just make sure I got this right. So the ID is here, 1 to 5. So this is 1, 2, 3, 4, 5. Oh, no, 4. Okay. 5, 6, 7 to 7 plus, and then 1, 2, 3, 4, 5. 5. No, I've still got it wrong. I've got it, here we go, there's the bug. Yeah, so this is actually 5, and this is, as in the diagram, 6, oh, 6, 6, yeah. Yeah, that's right, because we're reading 4 bits out of there. Yeah. Okay, great. So let's move on back down to reading the splice time. So this is now, as I've written, going to be 7, and then 7 plus 5, since we're reading 5. I wonder if we need to do it like this, because the splice time isn't always 5 bytes. It can just be 1, and why that is because you can, for some reason, you can set a time specified flag and then maybe only have 1 byte instead of 6. So let's read the next byte. So if 7 so we're checking if the flag is set and from the next byte. So in here actually contains a flag and then 1, 2, 3, 4. 2, 3, 4, 5, 6, and then 1 bit. So we'll go 1. So that's that byte, and then everything else we want. So this is going to have 1, 2, 3, 4, 5, 6, 7, 8, and then all of that. So 33 bits all the way along. So this is all 32 bits, and then that. So we get 33 bits. That's everything that we want. So it's so all of that is 33 bits. And that's the value that we want to extract if the flag is set. Okay, so we'll go from 0, then so what we're saying here is that if the if the what is this 33-bit time? Yeah, read the 33-bit timestamp or time. Okay, we're reading 5 bytes to get 33 bits. And then, but we can't just throw in, I don't think, we can't just throw in everything from the buffer because we don't necessarily know what these values are. So what we should do is we're going to do it like this. We're going to get we're going to, and then we're going to mask everything off except for the rightmost bit. So what we're going to do is set we're going to get this value, which is, we're going to need a bit mask of 0x01, because that's 0, 0, 0, 0, 0, 0, whoops, and then 0, 1. So that's our mask. One. So just one bit. So yeah, we need to skip the reserved bits because we've got 6 reserved bits there, and then the one before we've also, yep. Okay, so, and then we can append, and then we can just happily append the rest of them. So we can just get this, 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 this. 1, 2, 3, 4. Yep. So that will be a yeah, I mean, maybe we should just do it like this. 9, 10. And then read remaining 32 bits. And then finally, we can set the duration in our struct, which is this from there. Whew. How about that? Reading one number. All that thinking for one number. Crazy. Yes, it is. This is really the only number that matters, really. This is the thing that says, yeah, so just for context, this is the number that says, hey, you've got an opportunity to insert an ad at this exact time. And that's what this number is. So yes, people make a lot of money out of this exact number. a lot of money. So, got the duration. Oh, fuck. Okay, I think the rest is pretty easy. So we'll just go back to our splice insert. Oh, motherfucker. Wait, maybe we've missed something. Ah. No, all good, all good. Okay, all good. So now what we're going to do is read, go back to our diagram. So we've read the splice time. Now we're going to read the break duration. So let's see what's set. Duration flag, okay. So if now the duration flag is back a bit. So the duration flag is actually The duration flag is all the way back here. So this is at byte index number 6. Yep. So and the bit that it is shifted 7, 6, 5. That means this is wrong. Right? Yeah. So this is because the immediate is at 7, 6, 5, 4. 4. That's 3. So this is 5. So we check if the bit is set, and then if that bit is set, then we know we can decode a break duration, which is very similar to, yeah. Yeah. So this is going to be the one we want, so I'll just do that splice insert. Of the duration flag is duration flag set. Yep. Then we can try to decode. So this we actually have done. So this is their break duration. Here we go. This has to be a fixed, we can actually set a fixed size array here. Actual array in Go, not just a slice. It's going to be 5 bytes. So again, check. I need to do this as a diagram here. I'll do this. And then 1, 2, 3, 4, 5, 6. No, it should be just 5. Let's do this again. Okay, so this contains the auto return, whatever that means, and then the duration, 1, 2, 3, 4, 5, yep. So that's, all of that is the duration, so that's 32 bits, and then out of here, yep. So this is just a flag. 6 reserved, and then 1 bit from the duration. So what we want is all of that. The 33-bit duration out of there. So let's write the code. So what we're doing here is just seeing if the bit is toggled, then if so, then we set our own little boolean to be true. And then we read in the, we'll create a, how are we going to do this? We're going to create a little grab the last bit, which should really be the consistency. That's just 1. I don't know. I don't know when you're meant to use like hex or when you're meant to do this kind of shifting notation. Yeah. Oh. The rest of, from here on we read everything else. So we're going to read, yeah, everything else. So then we're going to read the uint 64 out of here. So the duration equals the uint 64 out of this. And that's big endian. Uint 64 from and I think that's it. So let's just check again. So we've got auto return is index 0. This is 1, 2, 3, 4. And we need to read it. We need to read a whole uint 64 because that's the only way. I mean, that's how we've represented it in our struct, is a uint 64, and we don't have bitfields in Go. So that's right. So we're going to read our array of 5, an actual array of 5 bytes, and then we're making, this isn't super clear to me, but what we need this for is because we're reading a uint 64, so we kind of need to wouldn't mind a little comment here or something that's just explaining what we're doing. So something like that. I mean, anyway, that's fine. Oh yeah, okay, good. So now we can just do this function here. So we're going to read our duration from Splice insert, where are we? Break duration here. So let's go. From the next, how are we going to do this? Okay, so what we'll do now is reslice. So just to make, we don't have to keep so many numbers in our head. So from here we will, if we've read a, let's get the names right. So this is actually splice time. Yeah. And then this is duration. So if we read a splice time, then let's reslice. So we'll just throw away all the bytes that we've already read because we don't care about them anymore. We're past it. So we're going to go from like that. So the next byte along is 11. We've read 10. Otherwise, yep, because that means that so in this branch, we've read up to index 10. So let me just get this right. Yep. So we're doing this here now. So what this looks like is that we, yeah, because this, yep. Okay, let me get this right. So in this branch, we've read up to index 10, but otherwise, we've only read up to index 7. So our new slice that we care about is going to be from 8 onwards. Otherwise, if we've actually read the splice timeout, we're going to read from 11 onwards. Yep. Now the reason we're reslicing is so that when we get into the next bit of code, we don't have to keep track of so many, where we're up to, because we're going to jumping all over the place. It's getting a bit confusing. So, I mean, arguably we could, reslice from here as well, but anyway, let's just, we'll get to that when we inevitably look at it again later and we go, how the fuck does this work again? So, let's go. So we're going to have, oh yeah. Hey, Venrix. I can't believe you're crazy enough to follow along with this stupid legacy shit. This Scotty 35 thing is really starting to drive me crazy. But it'll be really good when we've got this stuff done. It'll feel good, I think. All right, so let's go. Buff of, oh shit, no, we've really fucked this up. No, we fucked it up again. Yeah. Yeah. So this, okay. What we're going to do, we're going to set a variable. It says that we've set the, oh dear. If the cancel indicator, all right. So if this, god damn this fucking code. Let's do this here. Okay, now we don't have to worry about that later, so we don't even need the comment anymore. We can just go if do a flag, then yeah, because by doing this operation we were throwing away the bytes from before. Okay. Okay, so we read the break duration now from 0 all the way up to, well, we know we need an array of 5 bytes, so 0 to, yep. Oh, we can actually just do it in one hit. Although I don't think, because I think this is still a slice, so we need to convert that to an array. Don't know whether we, yeah, this is a bit clunky, but not really. But having the fixed size array is good because it, you know, prevents all these panics and, you know, length checking and everything. I can't remember how to do these array literals in Go. I think maybe we can actually just do that. So I think the compiler knows. I think it knows. We'll see. We'll get a compiler error if we can't do it, which is all good. Okay, so we've read the break duration. Okay, we've got 1, 2, 3, 4 bytes to go. 4 measly bytes. Unique program D is a nice, clean 16-bit integer, so we can just read that right in. So program ID. Oh no, yeah, we've got this here. Program ID, yep. Equals again, let's do this. How are we going to check for this? We'll just reslice again. Yeah, that's good, and then we don't need it. All right, there we go. We'll read all the way to the end. So inst Avail equals unit 8 of here we go. We're ready to return. This is a big, okay, we need to factor this out. This has got to be its own function because this is a bit too much of a big boy for one case in the switch statement, bit too big. Can we whoa. That's it there. Oh, right, yeah, okay. That is a big case. Uncle Bob isn't watching. Oh. Command type. Oh, splice insert. There we go. Okay. How do I do a splice? Array literal. Am I really just going to do this? Whatever. Would you look at that? Nice panic. Ah, yeah, okay. That's all right. Ooh. So the issue here is this kind of yeah, okay, so our test, we wrote this test back when we were only able to do decode one type of command. So where are we? So in the Splice info, so within a Splice info we have this command, and our test was written when we could only do this command. But we're now doing it so we can decode and insert as well. So what we need to do is just not write shit test code. So what we'll do here is we'll go if like that, yeah. Okay, and then now we're doing insert nil. Now we want to test. So what we're testing is if the insert command that we're expecting is the same as the one that we've just tried to decode. So I guess for now we could just do a deep equal reflect. From reflect, I mean. So that'll be something like insert. Yeah, it should be okay. Maybe. Give it a go. From info, from dereference info dot command dot insert. And we've got ourselves an error. I'll do this, just make this line a bit shorter. 1 equals. There we go. Okay, are we ready? I think now this is that all correct? Yeah. Let's give it a go. Ah, fucker. And a panic. Rough. Oh, interface. Oh, whoa. What are we doing there? No, look, there we go. Dang. So we should really do a type switch here. Now we need to, yeah, this is pretty boring code, but whatever. So now we're just testing if the yeah, not really great testing there actually. I feel like I don't think we even that's not
I'm actually going to get rid of that for now. Okay. Okay, great. So our subtests are working okay. So we've got this one, 14.2. So we know that our, I'm actually going to rename that the name of the test, because 14.1, like what the fuck does that mean? So let's get here and we'll go, I'm going to call this exactly where they get it from there. A little bit. Let's just do that. Okay, and then our next test is going to be called that. Cool. All right. So let's print out the field names, because I've got no idea what that is. All right, so a bit better. We get our good little Acme action there. We can even just put, let's put this here side by side. Okay. Okay, so we've got something wrong here. The problem is that we're not reading the splice time or the duration. Getting some nil pointers instead of some actual values. Is it? Oh yeah, nice. Good spotting. Thank you. Okay. So let's put that there. So this is want and got. Okay, so oh no, sorry, no, all good. One. Read the ID okay. Cancel out of network. Maybe we're not reading that bit correctly. So let's double check the order of the bits. So Splice info section is, oh no, the in command, yep, okay. 8, the first bit. Oh, am I off by 1? Should this be? Okay, that's again more. Alright, so we're going to go. Let's print the. That's correct, okay. So we're checking the correct bit. Well, we've got the right position, but I don't know whether we're checking the right bit. So event ID, and then we go down, Splice event, so the cancel indicator. Yeah, so again, we're just back to our so from here we've got I'm just looking at my pen and paper, so we're reading the out of network in from leftmost, program splice we skip, duration flag is next, yep, immediate is after that, compliance, last one, and then next 3 bits are reserved. Looks correct. If the immediate flag is not set, we need to read or begin to try to read, oh no, the splice time. How can, okay, maybe this is a case of where I've accidentally, oh anyway, no, let's just try again. Okay, so 2, 7. Let me check again. Okay, let's be very careful of our what exactly we're expecting. So here's our thing. No, this is just before getting rid of the throwing out the bytes. That is a good question. Yeah, did I set buff correctly? Yeah, no, but I could be off. I could be off for sure. You know what? Oh no. If cancel, you know what? This is very suspiciously like, so this is actually what I got, and this is what I want. Now, to me, it looks like everything else is very suspiciously like the 0 value. So I'm wondering whether I've got my if. Yeah, this is, okay, yeah, this is incorrect. So, yeah, ready? Else, all that. Because, yeah. You know, I really hate the way that in the spec, no, where is it? Splice insert. Okay. How, like, they use kind of like code in like what? If it was just a table, I think that would be really much clearer. If they use diagrams, for example, that would be handy too. Yeah, it seems like that, yeah. But just these little things like if splice event indicator equals 0, it's like, just tell me what you really mean. Like if, you know, like if, and you know, and there's all these double negatives, it's like the, you know, the, where was that negative one? There's one that's like, there's a flag in here somewhere that's like, not this, and if you know, like the double, triple negative fucking shit. I'm like, what? Okay. If cancel, yeah. If we're not cancelled, yeah, then go through and start setting stuff. So otherwise, that's it. I think we're good. So that's else. Yeah, okay. Now I wonder whether we could like do an early return here, so then we don't have all this. I feel like we could just go like, you know, but I'm not sure, because then we don't have to have all this indentation and blah blah blah. Any opinions on that? Or at least a break. Yeah. Because if we break out of that, then we're, yeah, and the early return, that is like a Go thing, isn't it? Let's do that. And I'll just put a comment here. Rebel Elder told us to do this. Okay, so we'll blame you when you know, when this thing hits production. Right. Now is that, yeah, great. Okay, let's do that thing.
I think so. I think so too. Ooh, juicy. We've run out of bytes. One, two, three, four. 1, 2, 3, 4. I'm missing a byte here. 8, 16, 24. Oh boy, here we go. 8, 16, 24, 32. Yeah. Let's do this. 8 to 12. Okay. Ooh, shit. I think we may have gotten it. Pretty close anyway. First thing I notice is that we've got like an address and then just the value. So let's this has got to be, I don't know that. Let's just do that. Oh. All right, so what did I do that?
this event ID compliance thing again. Yeah, that one's a real... That one I don't quite understand yet. That's a tricky thing in the spec. That's something about how the like the actual value of this, if it meets like certain criteria. So there's actually a way to like split this up into bits and say, oh yes, if the first few bits are set like this and the last bits are set like that, then the ID is compliant with this like whatever, like some weird vendor thing is. I don't know why there's a flag for it, because I'm pretty sure you can just calculate it at runtime. I didn't read so much that part of the spec. Anyway, beyond that, everything else looks okay. Like, we've actually got values for these. Maybe what we need to do is get a way to like, maybe a better way to diff these structs. Including dereferencing stuff. We could write a little function to, diff the structs, but I don't really like that. It's just more code. Look, for now, splice time. Oh yeah, no, that's right. Yep. Okay, so the splice time is equal the break duration. Oh, that's just duration. Okay, so we're definitely not reading this break duration thing correctly. There we go. All right, so let's go back to the code. We're in the break duration. There we go, read break duration. So we can actually just have its own little test here, which is great. That. So let's oh wait, no, duration to be that, so then the byte layout is going to be this is, something's wrong here, so that's, oh yeah, we're going to need to shift it. Anyway, let's get our test down, so the results should be pretty easy to see once we've got this down. Okay, so we've got C, CF. What are the bytes out of that? 1, 2, 3, 1, 2, 3, 4. 2C, CF, 5. And then four, 8, 12, 16, 20, 24, 28, 32, 36. Okay. Yeah, so looks like in here we're passing along we're see, so what we're sending in is this. So that isn't right. We've got so let's check if we're passing this in correctly, like we're handing over the oh no, sorry, not there, here. So we're so it's in here somewhere. 0, 1, 2, 3, 4. I think we need to shift this along. So rather here, we need to shift this along. So I think, yeah, because we only want the let's draw out a diagram. So I think what's happening is that we're reading a where have we got? We've got here, yeah. So we're sending in 5 bytes. 1, 2, 3, 4, 5, and then what we're sending into our binary, decoding the uint64 actually we're actually sending in something like this, quite a bit longer. So we're going, and then we've got the rest. So it goes like this. I think. So that means that so this is in the code that we're looking at. This is a 1, 2, 3, 4. And so then from, let's go like this. Yeah, okay, I've got it. Yeah. So yeah, no, this isn't right. So I think I need to, I'm not doing this right. So this, because I think so what it's doing is we're reading in a big endian number. That means that it's taking these values as well. So
what I so can I just do this? I often get confused by this sort of thing. Let's see. Oh, God, that's a big number. Okay, no, it's not that. But I want to maybe I can do it like this. This is the bit where I'm hitting my sort of low level skills here, but let's go like whatever low level skills I had, fuck. Okay, so if I do it like this instead, where I do it like and then add the rest of the array. And then append 3 just random bytes. So yeah, I feel like it might be clearer to. Anyway, let's just do this now. So and then at the end we just append some empty bytes to get enough for a Win64. Should get. Yep. So now what we've got instead is we haven't got this. We've got. Now we need to go. Can I keep going back? Here we go. There we go. Oh, there. So now instead we're doing this. And then these are just zeros. So then our value that we want, the value that we return could be this guy, and then shifted 1, 2, 3. 1, 2, 3, 4, 5. Yeah, shifted 3 to the right 3. So if we do no. The same thing. I feel like something like that in here. But that's definitely where our problem is. One, 2, 3, 4, 5, 6, 7, 8. Yeah, that's right. Let's try to maybe let's put this up here.
So we're clearing all the bits except for the rightmost bit here. And then 3, 4, 5, yeah, because from this one, we only want, if we do it like this, the bits we only want 4, 1, 2, 3, 4, 5, 6, 7. We only want this bit. We only want that one there. So that's why we do the bit mask of OX01. So we mask it there. So we go A0 masked OX01. Maybe I wasn't doing the bit mask correctly before. So let's do maybe fuck, we got it. Yeah, we got it. Woo! Okay. Yeah. So we just went, so our problem was we weren't doing this bit mask correctly. So all of this is, and this is also incorrect. So what we were actually doing the right thing in the beginning. So the right thing was this here, and then yeah, was actually to go so these are zeros, 3, and then we start passing them in like this. Here, here, here. These aren't zeros, they're just whatever else. And 5. So that's it. So our test, let's just write a little test just for this one little function. So break duration test. to CC OX 5. Yep, and then if 1 does not equal got. And that'll be X. Great. Okay, so 1 got, oops, equals 1 that. Great. So now that test should just magically pass. Okay.
Great. Okay, so that test passes, so that's good. So we'll just do this from, oh, you know what? We can even actually get this, instead of copy and pasting that value, we can actually just get it out of the test cases. Let's do that. Because then it's clear where we actually got the data from, rather than just another magic value, which is, you know, no good. Here. So this is just going to be sample 1. Insert duration dot duration. Again. Oh, command. Oh, yuck. Oh, command dot insert dot duration. Okay, yeah, that's good. Awesome. All right, so yeah, yep. Pain in the ass. But it's worse when, like, you're trying to quote a movie for some reason. The stuttering's so bad. Love that movie. Now we can actually dump this, at least dump that part, because we've got a more specific test, so we don't have to bloat this big test. Just gets confusing. And then could probably we'll leave that there for now. And we can get rid of this stuff because we already test all of that. We already write information about that in our diff. So that's good. And then they were just decoding stuff, so whatever. I think I'm almost at the end of this, just because it's almost 8 p.m. here. So I've almost been going for, well, right now I've been going for 7.5 hours. So, you know, a little bit. Yeah. Just seeing now, I'll need to, yep, okay. Let's start. So what we're going to do now is we're just going to, I don't know if people want to see this, so maybe I will swap this over to this. Yeah, great. Now, oh no, you know what I'll do? I'll do this. So we'll just check off where we got up to. All right, so we did add the next test. So we added a new test case, which is a different whole type of Splice, Splice info. So that's awesome. Decode other descriptors. No, we didn't get to that, but that's okay because, oh no, sorry, yeah, we did this one as well. So we've done that. Great. Okay, so that's where we'll move on from next time. So what I'll do is I'll just commit this stuff. So I'll just commit this, and then we are good to go. So I'll put this here. All right, so as I type these commits, yeah, no worry, man. Thanks for watching. Thanks for joining us all. It's super helpful. Learning a lot. I'm learning a lot. So I hope anyone else is, or they find it interesting, or I don't know, like seeing a weird text editor, right? I can't believe somebody else actually uses Acme. I think you're the first person. Every single day I do this, somebody asks me about the editor. At least one person asks me. But you're the first one to actually use Acme, Rebel Elder. So it's awesome. Congratulations. Yeah. But if there's anything, that people want to see, I'm all ears. Thanks, Geek Pirate, yeah. Now, I actually saw what people usually do is they do, I'm sure you guys all know, but they add like all the people who are watching this to another channel. So I'm just going to, I don't actually know how to do that. And I don't know if people want to do that. Do I go to, I actually have no idea how to do this. What do they call raid? Okay, cool. All right, so let's see where people want to go next. So if I go here, and then I guess I'll go to like the same, there we go. Whoa, what? There's 10,000 people viewing now? Geez, no wonder there's more people viewing this stream as well. I started when there were like 1,000 people, when everybody's asleep in the in the Australian daytime. Oh, look, there's weird. Geez, I don't know. Let's go right down. Here we go. Where do we think we should go? Didn't Pandora and then React. Roguelike RPG. Oh no, that's game stuff. I just Untitled. Ooh, wow. What's that? Oh, retro programming. Okay. That looks good. Game, web design. Who's doing the weird? There's a guy who's doing developing a video editor in Zig. That's I would definitely send people there. I was watching that. It was really cool. Oh, React, no. Builds, chat-based mud Twitch game in TypeScript. Yeah, that was the name. Yeah. Yeah, it is. Yeah, that was it. Yeah, I found that super interesting. I only watched a bit of it. Okay, let me. Let's do this first. Oh, okay. Yeah, that's on. And I need to follow these things. That sounds good. Old school users, hell yeah. How do you do this? So last miles. So do you do like this? Oh, Spark 64 number. Oh wow, yeah, awesome. Okay, this is good. Let's go. So raid last miles. This is cool. I need to follow this. Follow. Okay, guys. Thanks again. I should be back tomorrow, so ciao. Thanks for the good times. Raid last miles. Dang. Last miles raid settings do not allow you to raid at this time. Okay, well. See ya.